Hello class, today we'll be talking about 11.3 and we'll be talking about combinations. Remember last section we talked about permutations. And when we dealt with permutations, the order didn't matter. Now when we talk about combinations, we're going to say that the order doesn't matter. So let's look. So our objectives for today is to distinguish between permutations and combination problems, solve problems involving combinations using the combinations formula. So let's look at the definition of combinations. A combination of items occurs when the items are selected from the same group, no items is used more than once, the order of the items make no difference. So you need to make note. The order of the items make no difference. So that's the difference between permutation and combinations. So now it says note that permutations problems involve situations which order matters. Combination problems involve situations which order of items make no difference. So just keep that in mind when you're dealing with these type of problems. So let's look. Let's look at the actual equation for combinations. So the formula for combinations, the number of possible combinations, if R items are taken from N items, so it's NCR. Remember we did with NPR before. So now I'm going to say this is NCR, so N choose R. All right, out of N items, I'm choosing R items, all right, combination-wise. So we have N factorial over N minus R factorial times R factorial. So if you put all of this in the calculator, you have to make sure that when you do it, you put all of this in parentheses. Keep that in mind. So let's go and look at a question that we're going to use this with. So it says, how many 3-person committees could be formed from 8 people? So we have N, which is equal to 8, and we have R is equal to 3. Now, if you remember with the permutation question like that, they actually gave titles for each one. Now, order does not matter because everybody is on the same playing field, so this is a combination problem. So it's going to be 8C3. So we're going to have 8 factorial over 8 minus 3 factorial times 3 factorial. So it's 8 factorial over 5 factorial times 3 factorial. Now, me personally, I'm going to write it out. So I got 8 times 7 times 6 times 5 factorial, and that's all over 5 factorial times 3 factorial. Now, some people may ask, why didn't you go all the way to 3 factorial? Because I had 5 factorial, and that's bigger than 3 factorial. So I can go ahead and cross these two out. So when I have it is 8 times 7 times 6. Now 3 factorial is 3 times 2 times 1. And I know what? It's 6. So 3 times 2 times 1 is 6. So I can go ahead and do what? Cross some stuff out. So this goes with that. So therefore it's what? 5 times 7, which is 56 different ways. So just keep in mind if you remember how to reduce fractions, you'll be good. Now, if you don't know how to reduce fractions, put it in the calculator and it'll reduce it for you. So don't let this overwhelm you because it's easier if you have a calculator, you can just put it in the calculator. So let's read this question. It says in December 2011, the U.S. Senate consists of 51 Democrats and 47 Republicans and 2 independents. How many distinct 5-person committees can be formed if each committee must have 3 Democrats and 2 Republicans? So the first thing we have to do is figure out the different things that we have. All right? So out of 51 Democrats, I'm choosing how many? 3. So this is 51 factorial over 51 minus 3 factorial times 3 factorial. Now, when you put this in the calculator, so we got 51 factorial over 48 factorial times what? 3 factorial. Put this in the calculator, you're going to wind up getting what? 20,825 different ways to get that. Now we need to do what? We have to figure out about how many out of 47 Republicans, how many ways can I get 2 Republicans? So we have 47, choose 2. So it'll be what? 47 factorial all over 47 minus 2 factorial times 2 factorial, which this will just be 47 factorial all over 45 factorial times 2 factorial. Then when we do the math and put it in the calculator or do it by hand, we get 1,081 different choices. Now, if you notice, we have 2 separate combinations. Now we're going to use the fundamental counting principle that tells us to take both choices and do what? Multiply them. So it's going to be what? My 51 choose 3, which we already know what the number that is. And then it's going to be what? Times my 47 choose 2. And then we'll get 22,511,825. That's how many ways that you can do this. That's how many ways you can get the 5-person committees when you do this with 3 Democrats and 2 Republicans. Now, if you have any questions about this, make sure you hit me through Microsoft Teams or send me an email.